Hi, welcome to the fun probability problem solving sessions. And today we're going to solve a pretty fun but easy problem here. So is a group of the people consists of the 3 males and the 9 females are randomly divided into a 3 group of 4. What is the probability that each group consists of the 1 male and the 3 females? All right, so now here, after we finish this ones here, I like, I have, I have like a similar problem to let you practice, and it will look like here. So it's a group of tours consist of the 3 males and then 9 females, and they plan to visit 3 museums in New York City. And because of the traveling schedule, each person only has enough time to visit 1 museum. So they can choose museum number 1, number 2, and number 3. Each person can only find 1 museum to visit. So find the probability at the end. We ask the tourists. That means we find out each museum is visited at least by 1 male and 1 female. Okay, so let's see what what can we do about that. So, but let's take a look at the problems here, so we be able to kind of learning the process and the methods here. Okay, so let's go to our whiteboard. Okay, so here is the whiteboards here. Okay, so like when I try to do this type of the problems, I always kind of like to draw little pictures, to help me to, understand that. All right, so in here I have a 3 group, right? I need to choose here, and I total have 3 males and 9 females. So I total have how many people? I have 12 people, right? So in the simple space here, so out of the simple space, total number of the n in the simple space, it will be what? So out of the 12 people, I need to choose 4 to put in the spot number 1. So how do I choose 4? So I will say, okay, out of the 12, I take 4. So after that, I have 8 left. So I need to take the what? I need to take 8, then choose 4. So then the remaining just 4 over 4, that's 1. So this is my total, how many differences in the simple space, right? So it's C to the 12 to the 4 times C to the 8 to the 4 times C to the 4 to the 4th here. Okay, so this is my sample space here. Okay, so now let's see here. Now, if I said, okay, so now we want to find what is the probabilities, 1 male and the female. So I'm going to use the color green represent 1 male. So out of we have 3 males, right? And we have 9 females. All right, so now I will say, okay, so I want to have each one will have 1 male. So what is the chance I can put on the first one? Out of these 3, I can choose anyone, right? So I have 3 different possibility. After I choose 1 male, now how many left? 2 left. Now how many left? 1. Okay, so the same things here. Now I need to do the same way for females. So out of the 9, so how many I can do out of the 9? So I have 9. I need to choose what? Choose 3 here. Okay, so the same way here. After I get the 3, how many left here? I have 6 left, right? And then after 6 left, I have how many? 3 times 3 left. So this is my total combination, the total possible outcomes for if each committee will have 1 male and 3 females. So now the probability will just be pretty easy. You put your overall sample space number, right? So A to the 4, C the 4 to 4, and then here it is 3 2 1s, right? So 3 times 2 times 1 is 3 factorial, then times 9 over 3, 6 over 3, and 3 over 3 here. Okay, and the reason why we use the multiplications, remember, like in the statistics, you know, the one of the keyword is and. So if you know, if you see the meaning of the and, most likely it's a multiplication. So like in here, they said one male and 3 females, right? So that's why you use 3 times 9 over 3. Then we said committee number 1 and community number 2. So that's why you multiply all of them together, right? Okay, so this one, I say, is a pretty simple concept. Okay, now you should pause your video, and then let's go to take a look the problem we had. You know, our next practice problem is very interesting. The problems here. Okay, so is about like a group of tourists problem. So you should pause your video and try to take a look to see you be able to do this. All right. Hey, welcome back. I hope you try to solve these problems here. So let's try to understand these problems again. So it's a group of tourists consists of the 3 males and the 9 females. They plan to visit the 3 museums, right? And due to the time constrictions, so each person only enough time to visit 1 museum. So I want to find the probability at the end of the tour's time. We find out that each museum is visited at least by 1 man and 1 woman. All right, so let's see. How do we do these problems here? Hope your answer will match my answer. Okay, so let's take a look here. Let's go to our whiteboard. All right, so here's a whiteboard here. All right, let's go to the whiteboards here. All right, so first things here, still let's do here. I have a what? I have 3 museums here, right? So how many people I have here? I have a total, how many? I have a total 12 people. All right, and so in here, let's take a look at my total sample space n's here. Let's see how many I can have. All right, so for these 12 people, so like for example, this is people A, B, C, D, right? So for person A, you know, because it's 1 museum, right? 1 museum, you know, every person can do 1 museum. So person A can choose you know, whatever the museum to go to, correct? So how many chance this person can choose, right? So this person has 3 different chances here, right? So the A can choose here. Then for the B, we assume those tours, they are independent here. So for the B's here, so B also can choose 1 museum. So B maybe choose here. All right, so also the B has 3 choices here, so it's 3. Let's see C here. C can choose this one as well, right? So C has 3 different choices. Can choose which museum, you know, the C want to go to C. So what is the total number of the sample space? That means each one has 3 different choices. So the total number sample space is 3 to the what? 12 powers. All right. Okay, so now let's take a look here. Let's say at least. So now at the end, we said, okay, now I know at least 1 man and 1 woman. Okay, so we have 3 men, right? We have how many? We have 9 women. Okay, so at least 1 man and 1 woman. So that means, okay, for the museum, number 1, any of these men can come to see the museum, number one, right? So have three different the three different chances for the men come to see that. So after the one man come to visit, then because of the time, this person cannot visit the other museum, so have two and have one, right? So that is the, that is the probability we have here. Okay, so after that, then we say also at least one woman will going to see the museums here. So the first ones here, I have 9 chances here for any of the women going to here, right? After that, then the second museum only have a woman, they will go because the first one, they already go to the first museum that doesn't have enough time. So what I have here, I have 7, right? Okay, so after this, then they said at least visit once, right? So now what happens here? So how many women I left? I have 6 women left, right? So for these 6 women, they can go to any museums they want. So for these 6 women, total how many choices they have? Yes, what each woman can go to the museum A or B or C, right? So what is the remaining woman here? So the remaining woman, how is like what? Is 3 to the what? 3 to the 6 powers, right? Because each woman, they have the different way. So, or, you can, if you like, you can go like here. You said, all right, so the next woman's here. What is the next woman's chance? The next woman is what? 3. Then the next woman is right. It's 3. 3. So it's a total here is 3 to the 6 because each woman they can choose to go any one of them. All right. Okay. So now that's why I know my probability here will be so. The denominator is 3 to the 12. Then you have 3 times 2 times 1. So it's 3 factorial again. And times 9 times 8 times 7. Right? Then times 3 to the what? 6 factorial. Okay? So this one's here, it's the very similar concept like one before, but in here, because they say at least by a man and a woman. So at least by a man. So that means I need to choose any man to put a man into each museum. And then I choose each woman put in each museum. Then the remaining women, they can go anyone they want. All right, that's it. Okay, I hope that you match my answers here. Okay, so nice to talk to you about this easy and fun problems here. Okay.